So number one, again, it's asking us to list the possible rational zeros. We don't have to actually find which ones work, just the possibilities. So we learned something yesterday called the rational zero theorem. Again, it's on your formula sheet. If you forgot, look back at it. It says, let me write this to jog your memory. So what do P and Q mean though? So again, it does tell you on your formula sheet, P is all the factors of the constant term. So you need to think about the factors of 18. So 1 times 18, I like to list them so that they'll be in order when I'm all done. 2 times 9 and 3 times 6. And then Q is the factors of the leading coefficient, which the only factor of 1 is 1. So then again, the possible rational zeros are anything of the form P over Q, which means we take this number and put it over this number. So like positive or negative 1 over 1. But again, 1 divided by 1 is just 1. So then we have positive or negative 2 over 1, which would just be 2. Or negative 2, right? You got to put the sign every time. Then positive or negative 3 over 1, which again would just be 3, and so on. So your list should have looked like this. Okay, the next one says use synthetic division to decide which of the following are zeros. Like if you lay out synthetic division with -3 and do all the work, do you get 0 is the answer. Now, one thing I want to draw your attention to, remember guys, when you're laying out your coefficients, sometimes you need a 0 in there. I don't know if you guys notice that you do on this one because there's no x to the third term. It's missing. So like it goes constant, degree 1, degree 2, degree 4. It skips degree 3, which means remember that the coefficient is 0 if you don't see anything there, since 0 times anything is 0. So you'd put 3 for x to the fourth, 0 for x to the third, 5x to the square to the second, -17, and then your constant. And you would do your synthetic division. With -3, if you do all the work, you should end up with 348. So that didn't work. Okay, with -1, I'm not going to go through all of it. I'm just going to give you the answers. With -1, you should have gotten 34. So that's not what we're looking for either. When you fill in 1, it works. When you're all done, you should have gotten 0. So 1 would have to be one of the zeros. And then we'd have to check the other one too, because it could have more than one place where it crosses the x-axis. But if you plug in 3 and do the synthetic division, you're going to get 246, not 0. Okay, so 1 was the only thing that would have worked. So in today's lesson, it's a continuation of yesterday. So all the steps are going to be the same. So you already wrote this down in your notes yesterday. Okay, we're going to start by again listing the possible rational zeros, which is what like we did on the first question in the warm-up. Then we got to actually use synthetic division to figure out which ones work after we look at the graph to help us narrow it down. The only thing that might be different today is sometimes the P over Q list will be longer because, like, look back to the warm-up. Most of the problems you did on your homework last night had 1 as the leading coefficient. You'll see, like, on this first problem we're going to do, it's not a 1. So that might make it a little bit more work. You'll see as we go through it here, okay? So if we want to find all the zeros of this function, the first thing we're going to do is find the possible rational zeros, which is make that P over Q list. So let's think about what P is. It's the factors of the constant, so 1 times 8 or 2 times 4. Let's think about what Q is. It's the factors of the leading coefficient 2, so 1 times 2. So again, we got to put all these numbers over 1, right? Because you're always doing P over Q. So I'll just underline that. So you're going to do positive or -1 over 1, which is just 1. Positive or -2 over 1, which is just 2. Positive or -4 over 1, which is just 4. Positive or -8 over 1. Then you move on and everything has to be put over, all the p's have to be put over 2, right? Because you have to do every possible combination. So start here with 1, positive or negative 1 over 2, positive or negative 2 over 2. That just equals 1, right? And we already have 1 in our list, so we don't need to do it again. Positive or negative 4 over 2 would be next, but again, that equals 2, so we don't need that. And positive or negative 8 over 2 equals 4, so we're actually done with our list here, okay? Now, remember, we don't want to do synthetic division with all those possibilities. That's 10 possible answers, right? Because maybe it crosses at 1, maybe it crosses the x-axis at -1, +2, -2. We can't sit here and do that many rounds of synthetic division until we find the right answer. That'd be too much work. So that's why step 2, remember, is that we're going to narrow down our list, like see which ones of these look like they might be correct by looking at the graphs. So grab your calculator and we'll go to y equals, and we'll type our equation in, 2x to the third minus 5x squared minus 14x plus 8. And again, keep your list in front of you that we just made. Remember, guys, maybe graph works, but if it doesn't hit zoom and number 6, remember that makes it a standard window so that it goes from -10 to 10, and each little notch is 1. So like it makes it easier to see where does it look like it crosses the x-axis, maybe -2, and that's one of the things that was in our list, right? So the best thing to do, well, let's look at the other ones first, but the next one, if you move toward the right, like it looks like it's between 0 and 1. So maybe 1/2, because 1/2 is in our list, right? So potentially 1/2, and then 1, 2, 3, 4, maybe it looks like. But remember, you're just going to pick one of them. If I would not pick 1/2, if I were you, I'd pick an integer. So let's just go ahead and do -2. So what we do, remember, is we just try synthetic division with -2, lay out your coefficients, make sure, do we need any zeros? So we have x to the third, second, first, constant. So nope, we don't need any zeros because there's no terms missing. So we go 2, -5, -14, 8. I want you to go ahead and do the synthetic division, see if you end up with 0. So if you bring down the 2 and then you start, -2 times 2 is -4. Remember, we add straight down, so that's going to be -9. Do it again. -2 times -9 is +18. Add straight down, and you get 4. -2 times 4 is -8, so that's good. 8 plus -8 is 0. So remember, we know now that it crossed the axis at x-axis at -2. Guys, remember, what we're really trying to do is write this in factored form, because if we can get it in factored form, then we'll be able to tell all the zeros, all the places where it crosses the x-axis. So remember, if it crosses the x-axis at -2, the factor would actually be x plus 2, right? Because like if you fill in -2, -2 plus 2 is 0, right? So you just have to remember that's how you would write the factor. Now, remember, we started with a degree 3 polynomial. If we factor out x plus 2, what's going to be left is a degree 2 polynomial. Remember, these are the coefficients of it. So it's like 2x squared minus 9x plus 4. So now that this is degree 2, we can just go ahead and try to factor it. Like we can see, is there something that we can FOIL out that would give us that back again? So I'm going to let you think about that for a minute. So again, we know it's going to have to be 2x times x to give us 2x squared, right? And then you have to figure out what can we multiply to get 4. Now, hopefully you realize both things have to be negative, because look, the middle term is negative. So again, you just guess and check. So maybe it's 4 and 1. FOIL it out and see. 2x times x is 2x squared. Outer gives me negative 2x, inner gives me negative 4x. I'm going to stop right there because negative 2 minus 4 is negative 6. It's supposed to equal negative 9x. So I know that's not going to work. Remember, guys, before you go, like the other way to get 4 besides 4 times 1 is 2 times 2. But before you switch, like maybe it's still 4 and 1, but maybe the 1 goes here and the 4 goes here. FOIL that out and check it. 2x times x is 2x squared. Outer, 2 times negative 4 is negative 8x. Inner, negative 1 times x is negative 1. And yeah, that equals negative 9. This is going to work. If it didn't, then you would go on and try 2 times 2 and FOIL it out. Now, don't forget the x plus 2 here, okay? Like there's 3 factors in our answer. And now it's completely factored all the way. But remember, we were supposed to find the zeros. Like where does it cross the x-axis? What numbers can we plug in for x that make this come out to equal 0? Well, this factor would have to be negative 2, because remember, that's what we used in our synthetic division. Negative 2 plus 2 is 0. This would have to be 4. And then the middle factor, you might not just know the answer. You might have to write an equation for yourself. Like, how can I get this to equal 0? You'd have to solve it. So add 1 to both sides and then divide by 2. So it should be 1/2. So negative 2, 1/2, and 4. Those were all things in our list, right? Negative 2, positive 1/2, and positive 4, okay? And then I'm going to teach you a way how to check these answers on your graphing calculator. So hopefully you still have this graph up there. If you hit second and then trace, you're going to have this little menu come up, and I want you to choose the very first thing that says value. So remember how the first answer we got was negative 2. I want you to type negative 2 and hit enter. Look where it puts the cursor where x is negative 2, and look what it says at the bottom, y equals 0. So we know for sure that's correct. Let's do second trace again, and let's check our second one, 1/2. So hit enter, and yep, look at that. When x is 0.5 or 1/2, y is 0, and it's putting you there on the graph too. And then we could do it one more time and check our answer of 4. And yep, 4, 0. So we know for sure those 3 answers are correct. Okay. Any questions so far? All right. Now, we started with a degree 3. Next one we're going to do is a degree 4. So it's going to be just a little bit more work. The first thing, though, we have to have a starting point. If we want to find the zeros, we have to know the potential places that it might cross the x-axis. That's where we make that P over Q list, okay? So for P, remember, you're going to think of all the factors of 30. So the constant terms, so like 1 times 30, remember I list them like this because I want them to be in order when I'm all done. 2 times, by the way, guys, if you don't know what, you're just going to have to do 30 divided by 2 to find out, but it's 15. If you don't know whether 3 goes into it, you have to do 30 divided by 3. And then 5 times 6. So then again, we need to list the factors of the leading coefficient. That's what Q is, just 1 times 2. But we're going to have a lot of things in our list because there's so many factors in 30, and we have to put all these things over 1 first. That's easy though, right? Because like 1 divided by 1 is still 1. So our first set of numbers, since they're all divided by 1, basically you're just going to list these out. So positive or negative 1, 2, 3, 5, 6, 10, 15, 30, and then we got to put all these numbers over the other Q value of 2. So we would do positive or negative 1 over 2, positive or negative 2 over 2, that equals 1. We already have that in our list. Positive or negative 3 over 2, positive or negative 5 over 2, positive or negative 6 over 2. 6 divided by 2 is 3. That's already in our list. positive or negative 10 over 2. That equals 5. That's already in our list. Positive or negative 15 over 2. And then positive or negative 30 over 2, but you can use your calculator if you need to. 30 divided by 2 is 15. That's already in our list. So again, guys, those are all the possible rational zeros. Rational. I want you to focus on that word because later we're going to see what happens if the zeros are irrational, okay? So it might cross the x-axis at some of those places. But again, we got to narrow it down. We can't do sit here and do synthetic division with that many options, right? So we want to go to our graphing calculator, type in our equation. So we have, clear it out, 2x to the 4th minus 9x to the 3rd plus 37x minus 30. We should be able to just hit graph, okay? Again, if your window doesn't look like mine, use that Zoom 6 button first. So to me, it looks like -1, -2, maybe. So, and then let's check the others, maybe like +1 and +3 and something in between 2 and 3. So it looks like maybe 2.5. You could check and see if 2.5 is in your list. It is, because 5 divided by 2 equals 2.5. But out of all those choices, I mean, I wouldn't pick 2.5. I'd pick one of the ones that's an integer, right? So probably -2. Let's just start at the left and work our way toward the right. Let's start with -2. So you're going to go ahead and do a round of synthetic division with -2. Guys, when you lay out these coefficients, be careful because x squared is missing in here. So you're going to need a 0, right? So 2 for x to the 4th, -9. 0 for the x squared term, x term, constant term. Go ahead and do your synthetic division here and see what you get. So remember, we bring down the 2 and then we start -2 times 2 is -4. Add straight down, -9 plus -4 is -13. Do it again. -2 times -13 is 26. Add straight down. Do it again. This equals -52. Add straight down. One more time. -2 times -15 is 30. Yay. It equals 0. So again, guys, remember what we're trying to do is write this in factored form. So if the 0 is -2, remember the factor is going to look like x plus 2, because if you fill in -2, -2 plus 2 is 0. Now, if we factor this out, remember, if this is a degree 4 polynomial, what's left is going to be a degree 3 polynomial. So how do we know what? Remember, these are the coefficients of it. So 2x to the 3rd minus 13x squared plus 26x minus 15. So guys, if that were degree 2, we could go ahead and factor it. It's not. So we're going to have to do another round of synthetic division. So look back to your graph. We said that it looks like it crosses at 1. And that's one of the things in our list. So we know that that is a potential 0. So we have to do another round of synthetic division with these coefficients. So go ahead and lay them out. 2, -13, 26, and -15. And I'll give you a minute again to go ahead and do that synthetic division. So if you bring down your 2, 1 times 2 is 2, -13 plus 2 is -11. 1 times -11 is -11. Add straight down, we get 15. 1 times 15 is 15. Yay, it equals 0. So guys, remember, our first factor was x plus 2. Now our second factor is x minus 1, right? Because if the solution is 1, the factor looks like x minus 1. What's left would now be down to a degree 2 polynomial. Remember, these are the coefficients, so 2x squared minus 11x plus 15. So if it's degree 2, we can try to factor it by thinking, what can I FOIL out that will give me that? Okay, so I'm going to let you have a minute to think about that. So again, we're going to need 2x times x, so that's 2x squared. think about 15 for a minute, but you're going to need both of these to be negative because the middle term is negative, right? So maybe it's -1 and -15, maybe, or switched around. Maybe it's -3 and -5. Again, you just have to FOIL out things and see until you get it. This is what should have worked. Don't forget the factors we already found earlier. So this is now the complete factorization, but we're supposed to find the zeros. We can do that easily now that it's in factored form. Look at the first factor. X would have to be -2 because -2 plus 2 is 0. Look at the second factor. X would have to be 1. We already got those two answers earlier. I'm going to jump ahead to this one. X would have to be 3 because 3 minus 3 is 0. This one's the trickiest. You might not just know the answer. 2x minus 5 equals 0 is what you have to do if you don't know, and you have to solve it. So add 5 to both sides. So 2x equals 5. Divide by 2. So 5 halves should be the other answer. Guys, 5 halves, or 5 divided by 2, is 2.5. And remember, you can check it by that thing I showed you earlier, second trace. If you do 5 divided by 2, it's going to tell you it's 2.5, and it's going to put your cursor there, and you can see, yep, y equals 0. That's one of the places, okay? Questions on that one at all? Okay, last one we're going to look at today. Go ahead and copy this one down. Again, if we want to find all the zeros, we're going to start by thinking about what could the possible rational zeros be. So, in other words, make your P over Q list. So, P, remember, is all the factors of 42. So, 1 times 42, 2 times 21. I'm just going to slide this down a little bit because I'm going to run out of room. 3 times, again, if you don't know what, you're going to have to do 42 divided by 3. It's going to be 14, and then probably 6 times 7. If not, again, you just have to use your calculator to help you. Q could be 1 or 2, all right? So again, this is going to be a pretty big list, but first you're going to put all these things over 1. That's easy because anything divided by 1 is itself, so basically you just list all of these. Okay, and then we have to put everything in the list over 2. So positive or -1 over 2. Positive or -2 over 2 equals 1. We already have that. Positive or -3 over 2. Positive or -6 over 2. We already have because that equals 3. Positive or -7 over 2. Positive or -14 over 2. That equals 7. We already have it. Positive or -21 over 2. Positive or -42 over 2, that equals 21. We already have it, okay? So again, too big of a list. We should narrow it down by typing the function in our graphing calculator to see which of those answers look feasible. So 2x to the 4th plus 5x to the 3rd minus 18x squared minus 19x plus 42. All right. Let's start with the one on the very left. The first place it crosses the x-axis. If you look on the left, it looks really close to -4, but I don't think it is. Like, we could check like second trace and do that thing I showed you, and you'll see it's not, like, you can't see the cursor because when x is -4, y is 22. The cursor's way up somewhere where we can't even see it. So it must be somewhere in between -3 and -4. So let's just not worry about that one yet, okay? The other next place looks like -2. That one looks like it actually is like -2. So let's try it with synthetic and see. So let's take -2, lay out the coefficients. Make sure, do you need any zeros? No, because there's an x to the 4th term, x to the 3rd, x to the 2nd, x to the 1st, and the constant. You go ahead and do the synthetic, see if you get 0. Negative 2 times 2 is negative 4. 5 plus negative 4 is 1. Negative 2 times 1 is negative 2. Add straight down, you get negative 20. Negative 2 times negative 20 is positive 40. Add straight down, we get 21. Negative 2 times 21 is negative 42. So that's good. Remember, guys, if it crosses the x-axis at negative 2, the factor looks like x plus 2. What's left is still going to be degree 3 because we started with degree 4. If you factor out just one thing, it's still going to be degree 3. So lay out these coefficients. 2x to the third plus 1x squared minus 20x plus 21. So again, we can't try to factor that yet by just reverse FOIL because it's not degree 2 yet. We're going to have to go back to our graph because we need to do synthetic division again. Guys, remember that 1, 0 on the left, it looks like it's between negative 3 and negative 4. You could look at your list and see if any of the things in your list are between negative 3 and negative 4. This potentially could be because 7 divided by 2 is 3.5. So you could check, so negative 3.5. To me, it doesn't really look like negative 3.5. It looks more like negative 3.8 or negative 3.9, but we could check and see what happens with negative 3.5. Look at your y. It's not 0, okay? So look at your other potential answers. It looks like we have 1 and then 2. It doesn't look exactly like 2. Again, we could check and see if you plug in 2. Nope, it's not a 0. 2, 4 up there. So it looks like between 1 and 2 somewhere. Look at your list and see if any of the things in your list are between 1 and 2. This is, because divide it in your calculator. 3 divided by 2 is 1.5. So we're going to try 3 over 2 for our next round of synthetic division. So lay out these coefficients, 2, 1, negative 20, and 21. And you guys go ahead and do the synthetic for this. See if you get 0. So 3 halves times 2 should give us 3. Add straight down, we get 4. 3 halves times 4 should give us 6. Add straight down, we get negative 14. 3 halves times negative 4 gives us negative 21. Add straight down, and we get 0. So let's keep track what we have so far. Remember, the first factor we found was x plus 2. Now it would kind of look like x minus 3 halves, right? Because if 3 halves is the answer, the factor, because if you fill in 3 halves, 3 halves minus 3 halves is 0, right? That's why we write it like that. So now finally what's left would be degree 2. So these are your coefficients, remember? So 2x squared plus 4x minus 14. One thing that's going to be a little different, guys, than any of the other examples we looked at, there's a common factor in here of 2. So we want to pull the 2 out. I'm just going to go ahead and write it all the way in the very front. It really doesn't matter where you would put it because multiplication is commutative, but I'm just going to divide all these things by 2. Okay? And then sometimes, just so you know, like, we might take this 2 and multiply it into here just so that it becomes like, you could check 2 times negative 3 halves. It's going to give you an integer just so that there's no more fractions, okay? And then, but we don't have to do that technically, but usually we do. So we're going to think about, how can I factor this further? So go ahead and think about that for a minute. No, I made a mistake. Who knows what it is? I forgot to divide the 14 by 2. That should be a 7. Sorry. Now see if there's anything that you could factor that would equal that. But there's not, because x times x, like, there's nothing that could multiply to negative 7 and add to 2. So let's think about this for a second. Like, this can't be factored. let's think about the answers we know so far. This is x equals -2. This is x equals 3/2. We know because we did our synthetic division. So there's still two more answers though, because look at your graph. It crosses the x-axis 4 times, and we only found two of the answers so far. X equals 2, right? That was one of them. Or I'm sorry, x equals -2, I meant to say. So if you check it, there you go. There's one of them. And then if we do 3/2, which was the one we just found, there you go. It equals 0. What about the other two places that cross the x-axis? Well, they're not going to be rational numbers. Guys, remember we reviewed what a rational number is yesterday? Anything that can be written as a fraction. So like our final two answers, that list, if you look back, those are all the possible rational zeros. The answers don't have to be rational. So the last two are going to be irrational. So what that means is that since we can't factor it, we're going to have to use the quadratic formula to find the solutions to this thing, like what makes it equal to 0. If you look at your formula sheet, the quadratic formula is on there. We learned it in chapter 1, but it never goes away. That's why it's still on your formula sheet, okay? So let's review how to do this real quick. A is 1, B is 2, C is -7. So we're going to do x equals the opposite of b plus or minus the square root of b, so 2 squared minus 4 times a is 1, c is -7. It's all going to get divided by 2 times a is 1. So remember, you think what's in the underneath this square root. 2 squared is 4. -4 times 1 times -7 is +28. And 4 plus 28 is going to give you 32. The square root of 32 is not a whole number, right? If it was, we would have been able to solve this by factoring. So like you can punch this in your calculator. It's going to be an ugly number. Remember, we don't write down the ugly decimal. Let's go off to the side here. We want to simplify this. Like this is back from chapter 1. You think about what are the perfect square factors of 32. Now you have to be careful because 4 is a perfect square and 4 goes into that. But 16 is a bigger one. So remember how we wrote it as 16 times 2 because we were allowed to split it up? The square root of 16 is just 4, right? So we ended up writing it as 4 radical 2. So I'm going to come over here for a second. We have x equals -2 plus or minus. Instead of radical 32, I'm going to write the simplified version. 4 radical 2. It's all over 2. And then I just need to check if I can simplify any more. Yeah, I could divide everything by this 2. Like -2 divided by 2 is -1. 4 divided by 2 is 2. So these should be my other solutions. Like I'm going to write them up here with the ones I already found. So it would be like x equals -1 plus 2 radical 2. And then x equals -1 minus 2 radical 2. Now, again, guys, I could take this and plug it in my graphing calculator if I wanted to check it. Remember what I showed you? Second, trace, hit value. I'm going to do the -1 minus 2 radical 2 and hit enter. And look at that, y equals 0. But guys, I want you to look what the x value looks like. It's an irrational number, right? Remember one more time, that P over Q list helps you find all the rational zeros. This is not rational. That's why that was not part of our list. So whenever some of the zeros are irrational, you're going to have to do probably the quadratic formula in the end to finish it. If none of the things from your P over Q list work, it's because the final answers aren't rational. They're irrational, okay? So those are our 4 zeros for